Humans pumped and displaced so much groundwater in just 2 decades that we shifted the tilt of Earth's axis, new research suggests. Earth's rotational pole, the point around which the planet rotates, shifts with changes in the distribution of mass across the globe, wobbling and wandering in a process called polar motion. While scientists knew that changes in water distribution resulting from climate change could contribute to polar motion, the impact of groundwater depletion was unknown. Now, researchers estimate that by pumping 2,150 gigatons of water, almost enough water to fill Lake Victoria in Africa, and equivalent to the weight of 5.5 million Empire State Buildings from underground layers of water-saturated rock known as aquifers, humans caused a pretty significant eastward shift of 31 inches, 80 centimeters, in Earth's rotational pole between 1993 and 2010. That's because groundwater used for irrigation and other human activities eventually ends up in the ocean, which redistributes mass from where the water was taken to other parts of the globe. Earth's rotational pole actually changes a lot. Study shows that among climate-related causes, the redistribution of groundwater actually has the largest impact on the drift of the rotational pole. What's more, the extracted groundwater that ended up in the oceans may have boosted global sea level rise by around 0.25 inch, 6.24 millimeters. Groundwater depletion is a significant contributor to sea level rise, the researchers wrote in the study published June 15 in the journal Geophysical Research Letters. Globally, roughly 70% of the water pumped from the ground is used for irrigation, but only half of that trickles back down to replenish aquifers and other freshwater sources. The other half evaporates and ends up in the ocean through rainfall. To determine how much groundwater depletion and resulting sea level rise contributed to polar drift, geophysicists built a model of polar motion that accounted for shifts in water mass associated with thinning ice sheets, melting glaciers, and water storage in reservoirs. Other non-negligible changes in water and mass distribution may have played a role in polar motion between 1993 and 2010, including shifts in natural lake levels, mantle convection, and earthquakes. However, these are difficult to quantify, and no global database currently exists, the authors wrote in the study. While polar shifts recorded in the last few decades are unlikely to affect the length of days or seasons, the finding illustrates just how much water humans have pumped from the ground. The researchers have noted that the drift in Earth's pole almost 80 centimeters to the east will not affect the seasons on Earth. However, the researchers have alerted that the long-term effect of this change would be a massive impact on climate, gargantuan climatic changes.